Welcome to the session on quantum mechanical model of an atom. Now in this session, let us discuss about quantum numbers. See, what are quantum numbers? They say quantum numbers are the details which are necessary to locate an electron in an atom. Let me repeat once again. Quantum numbers are the details which are necessary to locate an electron in an atom. அதாவது ஒரு ஆட்டத்தில் எலக்ட்ரான் எங்கே இருக்கு அப்படிங்கிறத கரெக்டாக லொக்கேட் பண்ணுறதுக்கான டீட்டெயில்ஸ் தான் இந்த குவாண்டம் நம்பர். இந்த குவாண்டம் நம்பர்லேருந்து கிடைக்கிற டீட்டெயில்ஸை வச்சு நம்ம என்ன செய்ய முடியும், ஒரு ஆட்டத்தில் எலக்ட்ரான் எங்கே இருக்குங்கிறத லொக்கேட் பண்ண முடியும். ஆல்சோ they say to completely describe an atom or to completely describe an electron present in an atom, we require 4 quantum numbers. They are, say, number 1, principal quantum number. Then, number 2, azimuthal quantum number. Then, number 3, magnetic quantum number. And number 4, spin quantum number. So, each quantum number will provide us different details regarding the electron. So when you summarize everything, when you take into account the details provided by all these 4 quantum numbers, then we may have an idea that where an electron is present exactly. So let us learn one by one. First one will be, say, principal quantum number. See, this principal quantum number is represented by the symbol n, small n. This n can have a value of 1, 2, 3, 4, etc. Let us consider like this. So let us draw like this. First shell, second shell, third shell, fourth shell. Now you see K, L, M, N. Now I am writing correspondingly 1, 2, 3 and 4. Now what does this signify? See, this is the first shell, second shell, third shell, fourth shell. See, K stands for first shell, L stands for second shell, M stands for third shell, and N stands for fourth shell. So these are all the fixed path we have set. Now, using a formula, say 2n square, I can calculate the maximum number of electrons present in any shell. So you can see in this K shell, the value of n is equal to 1. So apply here. So for K shell, 2 into 1 square is equal to 2. What do you mean by that? It means that in a K shell, a maximum of 2 electrons can be present. Let us calculate for L shell. So for an L shell, 2 into 2 square, because the value of L corresponds to 2. So that will be equal to 8. So which states that in an L shell, a maximum of 8 electrons can be present. So in this way, we can calculate the maximum number of electrons present in a given shell. Then this principal quantum number tells us regarding the energy of electron. So we can calculate the energy of an electron using the formula. You see, En is equal to minus 1312.8 Ez square divided by n square. So much kilojoule per mole. So using this formula, I can calculate the energy of an electron. See here, n corresponds to the shell where the electron is present, or the shell number I can say, principal quantum number value. Z corresponds to the atomic number. So using this formula, I can calculate the energy of the electron. That information is provided by the principal quantum number, that is energy of an electron, and it also tells us the distance of the electron from the nucleus. So how far an electron is located from the nucleus. That distance can be calculated using the formula Rn is equal to 0.529 n square divided by Z, so much angstrom unit. So using this formula, I can calculate the Rn, we can also call it the radius or the distance of the electron from the nucleus. So these are all the informations provided by the principal quantum number. Let me repeat once again. It tells us the shells where an electron is present. Then the maximum number of electrons present in the each shell can be calculated using the formula 2n square. It tells us the formula to calculate the energy of an electron, and it also tells us regarding the distance of the electron from the nucleus. So these are all the details or the informations provided by, say, principal quantum number. Next, let us pass on to say azimuthal quantum number. Now the second quantum number is called as azimuthal quantum number. This azimuthal quantum number is represented by the symbol small l. Azimuthal quantum number can also be called as subsidiary quantum number. Now say the value of L starts from 0, 1, 2, 3, say 4, etc. Each value of L, what does it signify? They say each value of L represents a subshell. That is, see, 0 represents S subshell, 1 represents P subshell, 2 represents D subshell, 3 represents, say, F subshell. It goes on like that. So S, P, D, F. So these are the subshells. In other words, I can say orbital. So each value of L corresponds to subshells according to this particular azimuthal quantum number value. Then we can calculate the maximum number of electrons present in a subshell or present in an orbital using the formula 2 into 2L plus 1. Okay, so this formula helps us to calculate the maximum number of electrons present in any subshell or in any orbital. Using this one, we can easily calculate. And the other information provided by the azimuthal quantum number is that we can calculate the orbital angular momentum of an electron using the formula. See, orbital angular momentum of an electron can be calculated using the formula L into L plus 1 into h by 2 pi. So using this formula, I can calculate the orbital angular momentum. Also, they say this azimuthal quantum number say helps us to define the shape of an orbital. So these are all the informations provided by, say, the azimuthal quantum number, which is characterized by the letter small l. This azimuthal quantum number can also be called as subsidiary quantum number. Now let us discuss regarding, say, magnetic quantum number. Now what does this magnetic quantum number signify? And this magnetic quantum number is represented by the letter M suffix, say, small l. So that is a symbol for magnetic quantum number. And a magnetic quantum number M can have a value of minus L to plus L. So they say it through O means that 0 also will be included. For example, say if L is equal to, say, 1, what will be the possible values of M? You can see minus 1, 2 plus 1, which means minus 1, 0 plus 1. So in this way, we can actually take into account the value of M. So M value ranges from minus L to plus L. What does each value of, say, M corresponds? They say each value of M for a given value of L represents the orientation of the orbital in space. So it talks about the orientation. That is the important key word you have to remember. So whenever we talk about magnetic quantum number, orientation word is so significant that it tells us the orientation of the orbital, to in which direction that particular orbital is oriented. So that will be given by this magnetic quantum number. This is the main information given by magnetic quantum number. And also they say we have learned Zeeman effect. What is meant by Zeeman effect? We know that is a splitting up of a spectral line in the presence of magnetic field. So this Zeeman effect provides us the experimental verification or the justification of the existence of magnetic quantum number. So magnetic quantum number அப்படிங்கிற ஒரு quantum number உடைய significance this Zeeman effect கண்டுபிடிக்கக்கூடிய அந்த எக்ஸ்பெரிமெண்ட் வந்து நமக்கு ப்ரூவ் பண்ணுதுன்னு சொல்றோம். And other information what is given is that the direction of the angular momentum. So, okay, so that can be determined by this magnetic quantum number. So the direction of the angular momentum can be determined by magnetic quantum number. So these are all the informations provided by magnetic quantum number. Let me repeat once again. Magnetic quantum number is represented by the symbol M to the subscript L. It can have values of minus L to plus L, passes through 0, and each value of M to the corresponding L values signify or represents the orientation of the, say, orbital. So it represents the orientation of the orbital in space, they say. Then Zeeman effect provides the experimental justification of the existence of magnetic quantum number, etc. Then at last, let us discuss the spin quantum number. Now what information does this spin quantum number provides us? They say spin quantum number provides us only one information, that is the spin of an electron. We have learned that an electron not only rotates, it also spins around itself. So it spins in both clockwise direction as well as in anti-clockwise direction. So corresponding to these two spins of the electron, we have got, say, plus half value and minus half value. So this is represented by the symbol again m with the subscript s. For magnetic quantum number, m to the subscript L. For spin quantum number, it can be represented by the letter m to the subscript s. So a spin quantum number tells us the spin of an electron, and it has got two values, that is plus half value corresponds to say clockwise spin and minus half value corresponds to anti-clockwise spin. So as I earlier mentioned, that quantum numbers are the details which are necessary to locate an electron in an atom. So when you summarize all these quantum numbers, when you take into account all the details provided by the quantum number, we may have an idea that where an electron is present. So let me summarize it like this. Say principal quantum number provides us the energy of an electron or the details regarding the energy of the electron. Then this azimuthal quantum number provides us regarding the shape of the orbital and also the subshell. That information is provided by the azimuthal quantum number. Then the orientation of the orbital, that is in which direction that orbital is oriented, that information is provided by magnetic quantum number. And the spin of the electron, whether the spin is clockwise or the spin is anti-clockwise. So those kind of information will be provided by the spin quantum number. Now let us summarize the quantum number details with this tabular column. So the heading will be quantum numbers and its significance. See, let me repeat once again that the values, see, in the case of principal quantum number, n can have a value of 1, 2, 3, 4, etc. Then azimuthal quantum number L can have value 0, 1, 2, 3, etc. up to n minus 1 values. Okay. M can have value from say minus L to plus L, and S can have a value of say plus half and minus half. So these values you should memorize. See, let us apply these values here. See, in the K shell, we have learned that the principal quantum number value for a K shell is 1. Okay. So what will be the maximum number of electrons present in a K shell? We applied a formula 2n square. Based on the formula, if you apply n is equal to 1, you will get 2, which means that in a K shell, 2 electrons are present to a maximum. Now, for those 2 electrons, what will be the value of say azimuthal quantum number for a principal quantum number value 1? The value of azimuthal quantum number value will be 0. Why? Just see here. It starts with 0. So always the azimuthal quantum number value will start with 0. So that will be 0 here. Now, how to calculate the maximum number of electrons present in an orbital? We have learned the formula 2 into 2l plus 1. So in that formula, substitute this L is equal to 0, you will get the value as 2. So, okay. So which means that in that particular say L subshell, these 2 orbitals are electrons are present. Then what will be the value for magnetic quantum number? Magnetic quantum number value depends upon L value. You see, m is equal to minus L to plus L. Suppose if the L value is 0, automatically m value will be 0. So that is what is written here. M is equal to 0. Let us discuss that towards the end. Then likewise for an L shell. For an L shell, we have learned that the principal quantum number value is equal to 2, n is equal to 2. Apply the formula 2n square. That will help you to calculate the maximum number of electrons present in an L shell. So that will be equal to 8. Again, L value for 2 is equal to this, will see 0 and 1. When n is equal to 2, L will be 0 and 1. So these are the two values of L. So for L is equal to 0, again we will have maximum number of electrons in that particular subshell will be 2. Again, for L is equal to 0, as I just now said, m will be always equal to 0. Again, we have mentioned that. Suppose if L is equal to 1, then m value corresponds to minus L to plus L. So minus 1, 0, plus 1. You can see 3 values are possible. Similarly, for m we can describe. Only additional information will be, see, in the case of m, the shell number is 3, principal quantum number value is equal to 3, so 18 electrons will be present. There will be, say, for n is equal to 3, so the values will be, L value will be 0, 1 and 2. So there will be 3 values possible for L. If L is equal to 0, you will get m is equal to 0. If L is equal to 1, we have 3 values for m, minus 1, 0, plus 1. That we have discussed already. Suppose if L is equal to 2, m is equal to, you see, minus 2, minus 1, 0, 1 and 2. So totally there are 5 values you can see here. See, minus 2, minus 1, 0, plus 1 and plus 2. So totally there will be 5 values for m when L is equal to 2. Ipo, in the last one you see, I have given designation of orbital. These are the, say, symbols, or we can say these are the designations of the orbitals. And the orbital we will prepare so the 0 say m value 0 that is s orbital. We will discuss regarding these orbitals in the next session. At the time you will have a clearer understanding. Just now, for the time being, you just understand what are all the orbitals corresponding to the m value. So whenever m is equal to 0, it is always s orbital. Okay. Then again s orbital. See, again here also when m is equal to 0, s orbital. So wherever you have m value 0, it always you will have s orbital. Second, suppose if m has got a value of, say, L is equal to 1, then we mentioned that we have got 3 values which corresponds to 3 orientations and therefore 3 orbitals. Those 3 orbitals are px, py, pz. Likewise, when L is equal to 2, m corresponds to minus 2, minus 1, 0, plus 1 and plus 2. So totally 5 values which corresponds to 5 orientations and which corresponds to 5 orbitals, and they are, say, dxy, dyz, dzx, dx square, y square and dz square. So these are all the designations for those orbitals. This 1, 2, 3, this corresponds to the principal quantum number value, that's all. See, if this 1 corresponds to first shell, that is an s orbital is present in the first shell. Likewise, you see, this px, py, pz orbitals are present in the second shell, that is L shell. So this s orbital is present in the third shell, that is nothing but the m shell. Again, this d orbitals are present in this third shell, that is why you can see 333 here. So that number which comes before that orbital corresponds to that particular shell number. So in this way, we can explain the quantum numbers. Thanks for watching.